Mastering engineering vocabulary. Understanding finite element analysis. Hello, language learners and engineers alike. Today, we're going to delve into an exciting topic within the realm of engineering: finite element analysis, FEA. We're not only going to talk about what this means, but also discuss some associated words that you might encounter in professional and technical conversations. This vocabulary will enhance your ability to understand and communicate complex engineering ideas in English. Let's dive in. Finite element analysis, or FEA, is a computerized method that predicts how a product reacts to real-world forces, like vibration, heat, fluid flow, or other physical effects. The FEA breaks down a real object into a large number, thousands to hundreds of thousands, of finite elements, like little cubes. Mathematical equations help predict the behavior of each element. A computer then adds up all the individual behaviors to predict the behavior of the actual object. Keywords to remember: vibration. This refers to a back-and-forth motion. Fluid flow, the movement of liquid or gas from one place to another. Finite elements, small, distinct units that an object is broken down into for analysis. FEA consists of a computational process with three key steps: pre-processing, solution, and post-processing. 1. Pre-processing. In this stage, the physical system is defined. The system's geometry and physical properties are modeled, and the system's governing equations are written. 2. Solution. This is where the governing equations are solved across the model, generating an approximate solution to the problem. 3. Post-processing. Here, the results are interpreted and presented in an easily understandable form, usually through visual images, graphs, or tables. Keywords to remember: geometry, the shape or structure of an object. Governing equations, mathematical equations that define the behavior of a system. Approximate solution, an estimation or guess that is close to the actual answer. FEA is extensively used in numerous industries including automotive, aerospace, electronics, and biomedical. It helps in stress analysis, thermal analysis, vibration analysis, and more. It's a key tool that allows engineers to test designs, understand their behavior under various conditions, and make necessary adjustments before a physical prototype is made. Keywords to remember: stress analysis, the study of how materials deform under various types of stress. Thermal analysis, a study that involves testing a material's properties with the change in temperature. Prototype, a preliminary version of a product, from which other forms are developed. And that wraps up our discussion on finite element analysis. We hope this video has been helpful in expanding your technical and engineering vocabulary in English. With these new words in your toolkit, you're now better equipped to engage in professional discussions or to simply understand the intricate world of engineering a little better. Keep practicing, and we'll see you in our next video.